It's time to fire this thing up.
Welcome aboard ShipShape TV Essentials. This is your port of call for the most impactful upgrades, expert advice, and hands-on solutions from seasons past. This episode is proudly brought to you by SureHold, because anything worth doing is worth doing bright. From cleaning to protecting and perfecting, SureHold has everything you need to keep your boat shining. Don't just go boating, go showboating. Now, let's hoist anchor and set a course for another exciting episode of ShipShape TV Essentials.
Countersink the hole, screw it down, and I'm again going to let this glass out. Dry fit this thing into the boat. I think we are going to get lucky here. Hi, I'm John Greviskis. It's good to have you working around the boat with us. What I'm trying to do is I'm trying to mount this hydraulic ramp to the front of this engine. We've got a couple of holes here for a bracket, and we're going to be able to install this. Now, usually 70 horsepower is the cutoff point to where it's going to let you know if you're going to install manual steering on your outboard or hydraulic, and we're very, very fortunate. I got to tell you, we've got a great show lined up for you today here at ShipShape TV. We're going to be mounting this 70 horsepower outboard to a very unique project boat that I recently purchased. This is called an aluminum chambered boat, or an ACB. Now, we're also going to be getting into all the different techniques for installing the controls, and we're going to show you some of the different steering options that are available to us. So here's the deal. It's a trade-off. We need to get you to spend the next 30 minutes with us, and in exchange, right after I gather up some tools for this hydraulic ram installation, we're going to be letting you in on a few more ways to make your boat shipshape.
This is a real working 28-acre boatyard located in Stuart, Florida, on the shores of the Okeechobee Waterway. It's home base for ShipShape TV. This deep stretch of water connects the Atlantic Ocean to the Gulf of Mexico. And now, once again, here's the host of ShipShape TV, John Greviskis.
Thanks, Buck. This is a 16-foot aluminum chambered boat called an ACB. Probably looks a little bit different to you. That's because it didn't originate from these parts. This boat was first conjured up in New Zealand for the commercial fishing fleet, where they have 30 to 50-foot seas pretty regularly. Big, big stuff. Well, what happened was a company brought the boat over to the States and they modified the hull a little bit. And how I first got turned on to the boat was out in Newport Beach, Oregon, where I was invited to do a couple of different projects on some similar type boats for the Free Willy Foundation. You remember Keiko the whale? Well, they selected this boat to help in Keiko's release, the next leg of Keiko's release, off of the coast of Iceland, where you again have some very, very rough water. Now, what we're going to be doing today to this boat is we're going to be installing a 4-stroke, 70 horsepower outboard engine to the vessel. And what we need to do first is we need to mount a hydraulic ramp to this engine prior to putting the engine onto the vessel. And we're going to use this universal bracket to do it. Now, this will work on an OMC or a Yamaha or a Mercury, as well as a Suzuki. And how we're going to attach it is right here to the front of this tilt tube. We have 4 bored out holes here, and we're going to be using these stainless steel bolts to put it in. And if you notice, we have something on the threads. That's called Loctite, and that's to keep the bolt from backing out once the engine's vibrating out in the water. Now, we're also going to add another product to the threads of this bolt called an anti-seize. This particular product is a Tefgel product, which is a ground-up Teflon. But we're going to add these to the threads as well, because we're going to be boating in primarily saltwater with this boat. And what happens is when you put stainless steel into aluminum, after a short while, it can seize or freeze up on you. And this anti-seize will help that from occurring. Let me get this on. Now I'm going to put a little bit more of that anti-seize on the bolts that actually hold this ram onto this bracket, and then we'll get this all secure. That'll work nice. Now this outboard weighs about 220 pounds. What we're going to need to do is we're going to need to position it over here where I've got this A-frame set up. We've got some very sturdy legs along with a wooden beam. We've cut a couple of 2x6s to length, and that's what we're using along with this come-along. Now we're actually going to raise this outboard up and hoist it onto this aluminum transom, and thank goodness I have some professional help with me today. His name's John Eaton.
Hi, John.
Hello. He is the technical service manager for Suzuki Marine. I want to welcome you to the boatyard.
Thank you. I'm glad you had me.
John, can you tell me the difference between a two-stroke engine and a four-stroke engine?
Sure. Probably I should just start with the internal combustion engine in an overview. There are 4 processes to the operation of a internal combustion engine. Those are intake, compression, combustion, and exhaust. As you induce a fresh air fuel air mixture in on top of the piston, and that piston moves to the top of the cylinder, when it reaches the uppermost point, a spark plug fires, which creates an explosion that forces the piston back down. As that piston comes down, that creates the power that makes things happen.
Okay, now how does a two-stroke engine work?
Well, a two-stroke engine, the intake and exhaust is all done through ports in the cylinder wall. As the piston is coming up to compress that fuel-air mixture, it's also drawing fuel and air in through the carburetor into the crankcase. Once combustion occurs and the piston begins to move back down, the exhaust port is the first port on the cylinder wall that opens, and the pressures in that cylinder actually begin to force that exhaust out through the exhaust port. And at the same time, when the piston reaches the bottom, it's creating a pressure in the crankcase that forces that fresh fuel-air charge up on top of the piston on the other side, and starts everything all over again.
Okay, now how does a four-stroke engine work?
Well, a four-stroke has a mechanical valve setup. There's a camshaft in the cylinder head that actually controls the valve mechanisms, and as with the two-stroke and general internal combustion engine operation, as that piston comes up and the spark plug fires, it forces the piston back down. Then the exhaust valve will open so that when the piston comes back up, it forces the exhaust out through that open exhaust valve. Then that valve closes as the piston comes back down, and intake valve opens and draws another fresh air fuel charge in to repeat the process.
So it's not a port, it's a valve.
Right.
Okay. Where does oil come into this whole explanation?
Well, a two-stroke requires the oil to be mixed with the gasoline, and it requires that to properly lubricate the internal parts of the engine. A four-stroke has a crankcase, and that crankcase is a constant reservoir of oil that allows you to pump that oil throughout the engine to provide lubrication all the time.
What's a cleaner burning engine?
The four-stroke is a much cleaner burning engine because in a two-stroke where you're mixing that oil with the gasoline, that oil has to be burnt with the fuel. So there are unburned hydrocarbons that come out the exhaust on a two-stroke that you just don't have as much of on a four-stroke engine.
And this is across the board?
That's correct.
This is the same if it's a Mercury or if it's a Yamaha, Honda, or a Suzuki. Pretty much four-stroke is four-stroke, right?
Four-stroke technology is the same pretty much across the board. Everybody's got their differences. There's some differences in weight, differences, but some of them are carbureted, some of them have electronic fuel injection. Bottom line, most four-strokes give you a tremendous amount of low-end torque, which gives you much more control over your boat.
Excellent. Well, great explanation. Help me get this thing set up.
You bet.
Okay. We're again going to use that anti-seize on the through bolts that we're going to be using to actually mount the outboard onto the boat. But I want to show you something else that we're going to be using. This right here, this is a nylon washer. And the reason we're using this in conjunction with a flat washer is we want to keep the stainless steel bolt away from the aluminum. Again, we're trying to eliminate galvanic corrosion here. So let me go ahead and put this in. How are we looking? I think we're right there.
Do we need to go up or down, or?
I think we're right there.
Okay.
Here, let me. we gotta slide that over just a little bit, John. Well, the next thing that we're going to be getting into today is we're going to be mounting our control. Now, this is a single lever, dual function control. And basically what I mean here is this is going to control both throttle and shift. What I mean by that is we have forward, neutral, and reverse on the control. This is forward with a throttle advancement, or we have neutral, or we have reverse with, again, throttle advancement. And how the factory, ACB, set this boat up is they actually welded a panel into this boat, and this throttle is going to, or this control is going to actually mount right there. But before I do it, I have to insert the different throttle and shift cables that I need to use. And there are two that you can select from when you're rigging your boat. Now, one is a solid stainless steel wire that goes through a conduit like this. And if you have a boat that's under 20 feet in length and you don't have too many bends in your rigging tube, solid stainless is absolutely the way to go. It's going to be just fine. But if you have a little larger boat that has a lot of tight radius bends and turns in it, you might want to step up to the plate and go with something a little bit more expensive, like the ones that we're using today. Now, this has a wire rope inside it that's encased in nylon, and what's nice about it is it will handle a heavier load than the solid stainless wire. It'll hold 90 pounds versus 40 pounds. This will also make a tighter bend. This will make a 4-inch radius bend versus an 8-inch radius bend, but it's about twice the price. Now, once I got both cables attached to the control, we slid them through the rigging weight back to the engine and mounted the control onto the plate. Then we connected the shift cable directly to the shift linkage on the motor and then attached the throttle cable to the engine. To confirm our adjustment, we engaged the handle into each position: forward, neutral, and then reverse.
As John ties up some loose ends, let's see what the G-Man looks for when he's selecting a candidate that very well could be the next ShipShape TV project boat. Mr. G, what you got?
Well, Buck, what I do when I'm evaluating the hull of the boat is I take my fist and I tap on the side of the boat. This gives me some sort of reference to how structurally sound the boat is inside. Now, if it's rock solid, chances are you've got some real nice structural integrity. Take a listen to this. There's some big echoing going on in this hull. Now, if you're just going to be parked at the dock and enjoying the boat that way, that's fine. But if you're going to go out into any kind of seas and actually use the boat in some really, really rough conditions, listen to the side of the boat. Now, one note of caution here is when you are doing this technique, either at a boat show or somebody's home, make sure that you remove a ring or remove any type of watches. You don't want to be scratching anybody's gel coat. This thing sounds pretty good.
Hey, John, great tip. That'll help a lot of people. But unfortunately, the project is not complete, so let's get back into it.
Well, now that we have the control installed, the only thing left to do is to finish the hydraulic steering installation that we started at the top of the show. And thank goodness we have an expert with us in that field. His name is Dave Black, and he's with Morse Controls.
Hi, John. Nice to see you again.
Good to see you.
How can I help you out?
Well, I was hoping that you could tell our audience about all the different options they would have in steering.
Okay, I'd be more than glad to, John. Let me start out with what we at Morse make. We make a couple different mechanical steering systems, both a rotary system and a rack and pinion system, and also a hydraulic system, which you have installed on your boat today.
Okay, let's start off with that rotary system.
Okay. The first system we make is a rotary system that uses a helix cable.
Let me grab that.
Okay. The helix cable goes in one end, and that meshes with the gear inside. And as you turn the wheel, it basically operates a telescopic at the end, which pushes the outboard either to port or starboard.
This goes in the tilt tube.
That's correct. That's
Okay.
correct. Very simple system. Generally rated for boats under 50 miles an hour and the smaller horsepower engines.
Okay.
We also make a rack and pinion steering system, which consists of a helm, a rack attached to a cable, and the cable's a similar type cable, but the rack and pinion system has a slight mechanical advantage over the rotary. It'll handle a higher load, but it does have some space restrictions when you're installing it behind a dash with a lot of instruments behind there, not very much room, or center consoles.
Looks to me like we've got about, what, 18, 19 inches that
That's
we
right.
need to clear?
Yes, John.
Okay, so we have to make sure behind the dash.
That's right.
We have at least 18, 19 inches.
That's right. And we also make a dual rotary system, which is basically two helms put together, and we make a dual rack and pinion system. And we have some of the other manufacturers here which make those systems.
Hang on a second. There are basically 3 manufacturers of steering, right?
That's correct.
There's Morse,
Yes?
there's Teleflex,
Yes.
and there's Ultraflex.
Yes.
Okay. Now, let's get into this.
Okay.
Why would you use a dual helm setup?
Okay. A dual helm is generally used on some of the higher horsepower engines and boats that go over 50 miles an hour, and it's a little less expensive than a hydraulic system.
Okay, so what type of boat would use it?
Generally the bass boats up in the southeastern United States, the high horsepower, go fast boats, it's a little less expensive than a hydraulic system, and
I see that there's also a dual rack and pinion right here.
that's correct.
Okay.
And again, you can see how much space that takes up, so behind a dash, generally you don't have that much space.
Okay, now what's this?
This is a no feedback system, mechanical no feedback system, which basically operates like our hydraulic system. You do not get any feedback up through the system.
Okay, now let's talk a little bit about the hydraulic system. Now we already installed the ram on the engine.
Right.
What are some of the other components?
John, the system you're putting on your boat today is from Morse Controls, and it's the High Nautic High Track system for outboards. It basically consists of 3 component pieces: a helm, an outboard cylinder that you've already mounted, and hose connecting the two.
Okay. Take me through the installation.
Okay.
We already mounted the ram
Yes.
onto the engine. Let's start at the other end.
Okay. Basically, the installation on the helm is pretty easy. You already have a helm up there for a mechanical system. This bolts to the same footprint of that helm. We're basically going to bolt the system up. We're going to install 2 fittings on the back. Our system comes with,
Let's see those fittings
Okay.
that you're talking about.
Yep.
What mounts in here?
we have 2 90-degree fittings, and we're going to pull these pieces out right here, screw the fitting in, and then we're going to be able to hook up the hose to it.
What about right here? Do we have to drill a hole into the dash to accommodate this?
For this particular helm, we're going to have to drill an additional hole just to accommodate the fill for the fluid.
Okay, this is where you put the hydraulic fluid
That's
in.
correct, and bleed the system.
Okay.
Yep.
So we've got this installed.
Yep.
What do we do next? Put the hoses on.
Yes, we also supply in our aftermarket package a 50-foot length of hose, and we recommend cutting it in half, which gives you 2 25-foot lengths.
What are these fittings made of?
That's a brass swedged-on fitting.
Okay, and what's this hose made of?
It's a high-pressure hose. Our systems are rated at 1,000 pounds.
Okay.
So this is rated at a much higher rating than that.
So how do we put this on?
Basically what we're going to do is we're going to cut the hose in half. We're going to have 2 25-foot lengths. We're going to take the swedged-on fittings and attach them to the back of the helm. We're going to run the hose back to the outboard engine, and we're going to have some excess hose back there. So all we're going to do is cut off the hose at the correct length to hook it up to the cylinder. We're going to put the reusable fittings on, which is screw on, and then we're going to bleed the system, and we're going to have the system all done.
Tell me about bleeding the system.
Okay.
There are some tricks in this.
Okay.
How are we going to do that?
Okay. What we're going to do to bleed the system, John, is we're going to take a bottle of fluid with a hose, and we're going to lead it down to the fill on the helm. We're going to open up 2 little bleed assist screws in the back of the helm, and then we're also going to go back to the cylinder, and where there's 2 bleed fittings on the opposite end of the cylinder from where the 2 hoses go in, and we're going to hook up a quick connect bleed hose.
Okay, come on back to the
Okay.
cylinder and show me where those
Okay.
are. Okay.
These are the 2 fittings right here that we're going to hook up the hose to, and on the opposite end are the bleed fittings.
Where do we go?
Okay, we're going to hook up the 2 fittings to this hose. We're going to put the quick connect bleed hose on the other end. We're going to go back to the top to the helm. We're going to start filling the helm with fluid. And basically what we do is we turn the bottle upside down. We turn the steering wheel a couple turns in one direction, a couple turns in the other direction to get fluid into the helm, and then we can basically turn the system 40 turns in one direction. And we're going to watch the bleed fitting, the bleed hose, and make sure all the air has come out of the system. And about 40 turns should do that. Then we're going to reverse the turn on the wheel and turn it 40 turns in the other direction. And again, that should bleed the system, John. We should be finished, ready to go boating.
Well, Dave, I got to tell you, that was not that difficult at all. Thank you very much. You know, one of the advantages of putting a hydraulic steering system on the boat is they're virtually maintenance-free. All you need to do is occasionally check the hydraulic fluid level at the helm, and that's it. Well, the next thing that I'd like to get into is I would like to introduce you to the man that actually builds this boat. We work together out in Oregon on the Keiko project. His name is Larry Weber. And Larry,
hey John,
thank you for coming into town.
You're great to be here.
How's the whale?
It's doing great. I talked to Charles Vinnick at Ocean Futures yesterday. Keiko is doing fine, feeling good. They're getting ready to release him in the year 2000.
Good deal. Larry, you make boats from 15 to, I think, 26.5 foot. We have a relatively small vessel here. There's a 16-foot aluminum chambered boat. And I tested a boat very similar to this out in Oregon in some pretty rough water. I mean, these were like 15-foot seas that I was in. This boat has incredible soft landings. How do you do that?
Well, there's two basic reasons we do that, are able to do that, John. One of them is, if you look under here, you'll notice we use a traditional 18-degree deep V, and that slices through the water. But then they have a tendency to roll on you. So what we do is we stabilize that by putting this boat with 7 airtight chambers all the way around it. In fact, we wrap them all the way around the bow of the boat, as you see here.
Okay, now what's the advantage of these airtight chambers?
Well, this gives you tremendous safety. It's like having a life jacket around the boat. And up here in the front, when the water comes up, it curls back and the boat is actually landing with resistance on a wave that it's making. So it's riding on its own shock absorber, and that's what gives us tremendous ride. The boat only weighs, with the motor on, 650 pounds. So we're riding on top of the water rather than slamming through it.
I kind of liken it to snow skiing. This boat is kind of like going through powder. We're swishing.
We hear the word swish, squish, squeeze, that soft landing. It's coming down on itself rather than slamming.
Now, this is a double-hulled boat.
Yes, it is.
What does that mean?
Well, we have the outer hull here that's made by the chamber, and these are all airtight, and then we have the inner hull. And that's when we did our test. We actually punctured 4 chambers, top and bottom, put 4 people, and 1,500 pounds, the boat only went down 2.5 inches in the water, and that's what we talk about. It's probably the safest boat in the world, as well as the softest riding boat in the world.
A lot of the search and rescue teams are looking at the boat for rough water saves and things like that. Tell us about that.
Well, they like it because their operators are safe in the boat, soft riding. We just sold U.S. Search and Rescue here in southern Florida, is ordered a 2650. We're building a boat for the Ocean Futures, Jean-Michel Cousteau, for their whale studies. And we've had the Canadian Mounties test us, the U.S. Coast Guard. Several agencies from around the world have been in testing our boat because they've heard about how soft it rides in rough water for their operators.
Good deal. Well, Larry, thank you for flying into town. We also need to thank Aluminum Chambered Boats, along with John Eaton from Suzuki Marine, Dave Black from Morse Controls, and you for hanging out with us for the last half hour. But if I'm going to get this boat in the water anytime soon, I still need to put in the fuel tank, the gauges, and a couple of other amenities like batteries, so I better get busy. You know, there's a lot to owning an aluminum boat, and like I was talking to Larry Weber about, over the next couple of seasons, we're going to be getting into a lot more aspects of that type of boat maintenance. But you know the drill. This is the point of the show where we try to answer some of your questions, either through letters that you've written in via regular snail mail or through email. But before we get into today's question, which happens to be a good one, we need to give you our addresses.
Our mailing address is ShipShape TV, P.O. Box 31561, Palm Beach Gardens, Florida 33420. Or if you have internet access, the address is shipshapetv.com.
Okay, here's today's question. It comes from Bob, who lives in Baton Rouge, Louisiana. And Bob writes, Dear ShipShape TV, I was watching one of your programs where you mentioned that you accidentally drilled through your fiberglass hull when putting in a screw. I recently found a screw in my hull bottom, and when I removed it, I found that it wasn't attached to anything. But now that it was out, I had an 1/8-inch hole that needed to be filled. I used regular epoxy. Is that okay, or should I have used something else? Well, Bob, I think you're going to be okay with the epoxy. One thing I need to warn you about is when you do remove a screw from the hull, especially if there's any grease on it or any anti-seize like we were using in the show today, that needs to be removed. Otherwise, the epoxy plug could actually disbond from the hole. Now what I do is I take a slightly larger drill bit and I'll ream the hole out, and then I'll take some sort of a solvent like a denatured alcohol or an acetone, and I'll flush the hole, and then I'll fill it with the epoxy. Now I need to caution you, if that hole is 3/16 of an inch or larger, don't just go with the epoxy. What you might want to do is take a wooden dowel and drive it down into that hole, and then take a Dremel tool. Ream the top of fiberglass, give yourself a little bit of a dish, and then put in some new fiberglass with epoxy resin. Ferret, and I think you should be all set to go. Bob, excellent question. Thanks for writing in, but we're all out of time. How about doing yourself one last favor? Get out there, keep your boat ship shape.